Okay, hello everybody. Thanks for coming to my, whoa, that's a big one. To this talk about monoliths and microservices. Just a short introduction. My name is Nikola Zivkov. I work as a technology line manager for Java at a company called Civus. I'm based in Macedonia. First time here in Krakow, so lovely to see all of you here. Okay, so microservices are not a new thing. I'm sure that all of you are well familiar with the concept. It has been present for the last 5 years, I would say. So maybe some of you have already been using microservices. Okay, so I think that the concept of microservices is relatively well known, what the advantages of microservices are, why they were invented in the first place. And one of the key questions that developers are asking themselves, especially when starting a new project, is whether they should build their architecture into the direction of supporting microservices, or if they should be sticking to monoliths, what they have been using and developing for their entire career. So this looks like a decision that needs to be made during the first couple of months in the development of a new project, because we tend to think about architecture as something which is, we define it up front and we don't change it over time. So it looks like if we decide to go monolith, then we're going to need to stick to monoliths until the end of the project. Or if we go into microservices, that means that we will be able to support microservices later on. And there is a good, the internet, the developers are divided in their opinion about whether it's possible to switch between the two and whether you should go actually monoliths first or microservices first. So the first group that says that you should stick with monoliths first has some very good arguments about why it is better to develop your application as a monolith first and then switch to microservices. The first thing is the Yagni principle, or you ain't gonna need it. Simply said, not every application needs to or will eventually evolve into microservices, because you will never need all of these capabilities that microservice architecture provides. Another big problem with microservices is that service boundaries are very hard to get at the beginning. Basically, the first 6 months or 1 year during the development of the project, many things change. Clients change their requirements. Technical decisions need to be changed because you can't get them right at the beginning. So if you make a mistake into defining where the boundaries of which microservice lies, then it would be very difficult to make any refactorings. If you want to, let's say, split a microservice into 2 or more microservices, or maybe you have found that 2 microservices are too chatty, so you want to join them together. Because microservices usually reside, their code base resides in different repositories, etc. Doing all these refactorings can cost you quite a lot of time. And of course, there is the problem with the DevOps part of microservices. If you want to be doing real microservices, then it comes with a set of, let's say, practices that you need to employ, such as continuous delivery, rapid provisioning of infrastructure, rapid application development. You want to have central logging because you don't want to chase your bugs in a cluster of 10 or more servers where microservices reside, etc. And you want to have monitoring because there is not a single process that you want to monitor. There are 10 or more processes. So in case something goes down, there should be a central tool that tells you, okay, this microservice is now down, needs to be restarted, etc., etc. So during the initial part of each project, if you go microservices first, the team will actually need to spend quite a lot of time implementing all of these things, which it's very likely that you actually don't need them at the beginning, because at the start of a project, you're focused on developing new functionalities, etc. Arguably, the number of clients that will be using the application is not high. So Typically, you don't need to have all this the capability of horizontal scaling that microservices provide. So you would say that at the beginning, all of these things that you need to implement because you're using microservices are just some type of overhead that costs you quite a lot of time that you would rather be spending developing new functionalities for the client. In terms of productivity, the previous slide said that, also already mentioned this, so the productivity with the monolith is higher at the beginning. It's because you don't have to spend all of this time worrying about all of these things that microservices require, such as the DevOps thing. The thing is that as time goes by, there is this tipping point where the productivity of the team falls, if you're doing a monolith, falls below what a team working with microservices would actually have. The reason for this is that over time, the code base starts to get big. It's much more difficult to work without code base, etc. So over time, it would be, as you can see, it would be better to have been working with microservices. So ideally, what you would like to do is the following. You would like to start with a monolith, and then after some point in time where the productivity of having a monolith is just not good enough, then you would like to switch to microservices. But this is the ideal path. So the reason why this is very hard to do is actually the key reason why the proponents of microservices first approach, what they say, it's very hard to cut up a big ball of mud, a large monolith, into a set of microservices. And we have all been working on monoliths, which are quite big applications with a lot of code. And as soon as you start, you want to venture into microservices because this is the new architecture everybody is using, and you try to decouple your monolith into microservices. And it turns out this is a very hard thing to do. And the reason for this is because our monoliths are actually very often implemented as it says here, as big ball of muds. Basically, instead of having well-designed components internally, we tend to have code which is intertwined and very, very hard to split up. And the question, why does this happen, has to do with something called code entropy. Same as in physics, if a system, the larger the system, the entropy of the system, the higher the entropy of the system, or the disorder of the system. So you all know that for every new project, the first couple of months, everything is well structured. We follow our developing guidelines very easily. But as the team increases in size, as the code base increases in size, we tend to take shortcuts, etc. So over time, after, let's say, 6 months into the project, already things start to become heavily coupled inside the code. Whereas with microservices, because each microservice is its own separate code base, it is much smaller code base, which means that over time, the entropy of that system or the disorder of that system will be smaller than if all of these microservices were just one single monolithic code base. So this is what I would say 90% of the projects implement. It is the so-called layered architecture. Many of the books, the literature that developers use to educate themselves propagate this layered approach as a good way of splitting concerns. So typically you would have a presentation layer, a service layer, a domain layer, and a data access layer. And ideally, if you have 3 different functionalities in here, you have A, B, and C. So it could be, let's say, like in the previous presentation, you have like a shopping cart, and then you have a product functionality, etc., or a recommendation engine, etc. So ideally, they would be structured like this. So each of these components, functionalities, would have its own controllers, services, domains, entities, and repositories. The reality is that this is often the case. And the reason why this happens is because there is a single monolithic code base and developers just use whatever they can find in the code. We are taught that we should be using private protected or package protected classes, etc. But usually everything is public, everything is available, so developers just use whatever class they find in the code base, and they don't pay too much attention about how to structure the code, and at the end, this is often the reality. So everything, as you can see, is coupled together. So you can imagine if we would like to turn this monolith into a microservice, set of microservices, 3 microservices in this situation later on, that would be very difficult because there is evident coupling between these classes which belong to functionality A, B, and C. And the reason why this happens, this is one of the key things I want to mention, is because of this model code gap. When we're starting a new project, we're using this whiteboard, drawing all these boxes like components, and we say, okay, this is going to be my product catalog, is going to be talking to this shopping cart or this recommendation engine, etc. So all of these boxes exist on the whiteboard, but once we venture into code, once we start writing code, our code usually ends up in a structure which looks like this on the right side. We typically have, let's say, company project, like Civus project A, and then we have the layered architecture. Our packages usually represent this layered architecture. So we would have data access, domain, presentation, and service, just like we had on the previous slide. Who here is using this package structure in their project? So at least half of the audience. Okay, so the problem with this approach is the model code gap. What is the model code gap? Basically, the model which we designed at the beginning is nowhere to be found within the code. So if I ask you where is the product catalog or where the shopping cart is, there is no evident place in our code base where you can find all of the classes which are related to this functionality. Actually, there are classes that represent this functionality, but they are scattered inside these 4 packages. So you would find the controllers of functionality A within the presentation package, the services in the service package, etc., etc. So developers, if you tell a developer you should be working on component A, he would basically need to find all of the classes in all of the 4 packages which are related to this functionality. So to demo this problem, I'm going to present this simple application, a Bookstore application, which also consists of 3 individual components, and we will analyze the structure of the code and try to split this Bookstore into separate microservices. So let's see how easy, or is it not easy, to split a monolith into microservices. So I'm going to start the application now. Sorry. So the first version of the Bookstore is a complete monolith, the way we're used to implement them using layered architecture. So just to show the application, we basically have a set of books which are obtained from the book catalog component. Each book has information about it, title and author, a genre, and a rating from 1 to 5. Once I click on a book, I get detailed information about that book, and I'm also able to rate the book with stars from 1 to 5. So Here, we envision that we have like a rating component. You would typically want to have like a separate microservice for your rating because it will be able to scale independently, etc., etc. And on the right side and below, in the right corner, we have the recommended similar books. So typically, the output for this information would be from a separate component, let's say a recommendation engine. So logically speaking, we have three different components. We have the book catalog at the top, we have the rating component here, and we have the recommendation engine. Now, let's take a look at our code base. I'm going to open the Monolith application, and as I mentioned before, we have our application in several packages which depict the layers of the application. So we have the presentation, where we have the controllers, the book res controller, the rating, and the recommendation for the three different components. The service layer, we have the book service, the rating service, the recommendation service, the data access, etc. So it should be relatively easy to split this application into three different microservices. But in reality, if we take a look at the structure of this application, what we will see is that the three different components are actually using a common part, which is the book entity and the book repository. So in essence, as this is all, of course, a simplified problem than the one that I demonstrated, I showed earlier, but already you can see that there is coupling between these three components. So although from a logical point of view, we have three different components, hence that would be three different microservices, the thing is they're using common infrastructure, they're using classes which are shared, and they're using a single database. Now we know that in order to be able to split this application into microservices, they need to have their own independent code, and one of the things with microservices is that you would like to have an independent database. So each of those microservices should get its own database. Otherwise, you have coupling on infrastructure level. Basically, if you create a downtime on database level for one component, that would mean that all of the other components, actually all of the other microservices, will also experience downtime. And this eventually goes against the very principle of microservices, which says that microservices should be completely independent on code level and also on infrastructure level. So in order to be able to split this monolith into a set of microservices, we need to make some changes to our code base so that these three components are not tangled up together. So what we need to do is actually to create the following structure. In this situation, these four groups which we have represent different components. And actually, they would also get in the different packages in the code base. Already you can see that there is no single entity book and one single book repository together with a database, but each of these components get its own entities and gets its own database. So in the recommendation component, we have an entity which is called product. In the book catalog, of course, we have the book entity, which was there in the first place. But in the rating component, we also have something which is called the product. So we can already see there are two new entities called products, and we're keeping the old book entity. And what also we can see something at the beginning, which is called a message bus, and I will tell you in short about this message bus what it is. Let's just quickly have a look at the code base. So already we can see that the complexity of the application in terms of number of classes, etc., has started to increase because we don't have a single entity. We now have more entities, more repositories, etc. And the different thing here is that we no longer have our code organized into layers. Instead, we have a package structure which depicts the functional components of our application. So within my Bookstore application, I have a book catalog, I have a messaging, I have a rating, I have recommendation, and I have an API. So these are functional components, and previously I had layers as organizational structure. So what is the messaging part? What happens with this type of architecture is that we have, in order to be able to have the components completely independent, we need to be able to have parts of the information replicated into other components. In order to be able to, and we can see this on the following slide, basically, what we are creating here is a so-called context map. So these three entities, the book entity and the two product entities, are not completely unrelated. They actually they are different representations of the same thing, but in different concepts. And this is what, in domain-driven design, we refer to as bounded contexts. Basically, when we develop a component, we need to develop that, we need to think about only the functionality, enough functionalities or features in order to support that component. So for a book catalog, if we want to list information, what we want to have is title, the author, and the genre. For the rating, when we're rating a book, the only thing that we are interested in is the actual rating, so the star from 1 to 5. And when we're doing a recommendation for similar products, we want to be able to find, so a similar product is defined as, let's say in this situation, a book that falls into the same category and ordered by the star. So you typically will have a list of similar books that fall into the same genre, and they are ordered by the rating. So the higher the rating, that book will be displayed actually first. So for the recommendation component, we can see that this component is not interested in the title or the author. It's interested in only the category, because it wants to filter the products based on the category, and also the rating because it wants to sort the results based on that rating. And you will see that there is this UUID field, which actually links all of these three entities together. UUID stands for Universal Unique Identifier. So basically, there should be a book entry in the database and a product entry in the rating database with the same UUID. Because once you make an update, let's say, of the book, then you would like maybe to have this information propagated to another component. So a typical scenario is whenever I rate my book, this information needs to be available in the recommendation component. Or if I change the genre, it also needs this change needs to be available in the recommendation component. And the way we do this is actually through this message bus. So with microservice architecture, you typically use some sort of message bus in order to propagate changes from one component to another, from one microservice to another. Bear in mind, this is very different to the traditional enterprise service bus that was used in SOA architecture. When we're talking about message bus, we're talking about some simple form of messaging, such as RabbitMQ or Apache Kafka. And you can use it directly, or nowadays you have very cool frameworks in the Spring Cloud ecosystem, such as Spring Cloud Stream, which is ideal for this type of events. So this is also related to domain-driven design. For those of you that are familiar with DDD, the concept of domain events. So whenever something happens within one domain, let's say in the rating domain, in the rating microservice, this information needs to be propagated into other microservices, into other components. So typically, maybe a rating event is being triggered and is being sent over the message bus, and then whoever is interested in this information can pick up this information and update the local components database. So with this type of architecture, you do have some redundancy in terms of data being present at multiple locations, but at the end, this is what you need to do if you want to evolve into microservice architecture. So let me just start the application as a structured monolith. So this is the so-called structured monolith. So it's more or less the same code base, of course, with each component getting its own entities, its own database, etc. So I'm just gonna fire up the second version of the application. There should be nothing different in terms of what the end user will see. So the application will be the same one. But in the backend side, so you can still see I'm getting the books, I'm able to rate the books, I'm able to get the recommended books, etc. But what happens in the background, actually, I'm now using 3 different components, and I'm using 3 different databases. And it is the API gateway, which sits in the front, which actually combines the information from all of these microservices together. There are many different flavors of API gateways that you can see, that you can use. In this situation, I'm using the so-called composer pattern. Basically, the API gateway, whenever for example, it needs to get information about the book, the title, the author, and the genre is obtained from one microservice, from one component, the book catalog, but then it goes to the rating component to get the information about the rating and present it here. So actually, I'm combining information from multiple databases. So now let's see how difficult it is to actually split this application into microservices. What I'm using at the moment is this architecture. The red boundary indicates that every component is actually runs as a single process. So the red boundaries are process boundaries. So we have at the moment 4 different components which are run inside the one process, one application. Although I'm using 3 different databases as infrastructure, and I'm using RabbitMQ as a message bus. So in order to be able to split this application as a separate set of microservices, I'm going to stop the monolith, and I'm going to fire up the microservices one by one. Just let me show you the code base for microservices. I pretty much have the same, I'm using the same classes as I do for the structured monolith, but in addition, I just add Spring Boot application classes in order to boot up all of the different components. So for the book catalog, I have a single Spring Boot application, so nothing out of the ordinary, and I also provide an API client and a controller. And I need this in order for the API gateway to be able to talk to the component. So if I want to talk from, when I'm using a single application, the communication between the controllers and the components, it's a direct, using dependency injection, I just talk class to class, Java class to Java class. But if I want to deploy all of these 4 components as microservices, then the luxury of in-process communication is no longer available. I would need to switch to some other type of networking protocol, and most developers are familiar with REST. So basically, I need to expose the API of each of these 3 components as a set of REST services, REST endpoints, and then these are going to be used by the API gateway. So for the book catalog and for the rating, again, I have an application to start it, and I have the client and the controller, and also for the recommendation, I still have the same structure. So I'm using the components which I already developed for the monolith, and now I'm just going to try to start them as a set of microservices. So let's see if this starts well. So the first thing that we want to have, or we need when we're working with microservices, is service discovery. In a microservice architecture, You don't want microservices talking to other microservices based on their endpoint, their IP addresses or host names. You want to use something like Netflix Eureka for service discovery, which basically each microservice, once it starts, it registers itself with the Eureka, and then other microservices can find it. In this situation, the API gateway, the API gateway microservice, when it receives a request from the front end, it needs to find the appropriate microservice, so whether it's the book catalog, the rating, or the recommendation, but it doesn't do that based on an IP address. It asks an Eureka service to get an IP address, and then using that IP address, it's going to call the microservice. So I'm going to start Eureka. I have a separate static resources service to provide the images, etc. I'm going to start the API gateway as a microservice, and I'm going to start the book catalog first. So with microservice architecture, the key point is if one of the microservices is down, the rest of the application should function smoothly. So if you're not able to rate a book, okay, that's not a very big problem because you're still able to see the books, you're able to maybe purchase books, etc. So one of the microservices, if it's down, the rest of the application should continue to function smoothly. Okay, so let me just start the browser again. Just a second. Okay, the web UI is down. Okay, so you immediately see that we get response from the book catalog microservice. What you will notice is that the rating is currently not present. This is because the rating microservice is currently not started. So I'm only getting the information which the frontend could obtain from the book catalog service, but not from the rating service. If I click on a book, I get the detailed information, but I'm not able to rate the book. It's because the rating is not available, and also you can see that the recommendation for similar books is also not available. It's because the third microservice is also down. So let me just start the rating service, and we will see how the application will behave. So basically, once the rating is up and running, we should be able to see the ratings, and we should be able to rate the book. And this is what you would typically want with microservice architecture. Every microservice should be independent from other, and they should just add additional functionality to the overall application. So I just have a basic application, and let me just open Eureka. In the meantime, we will see which services are already registered. We can see that book catalog is registered, rating is registered, static resources, and the API gateway are all registered. So as soon as, okay, rating is currently up, it has been registered with Eureka, and you can already see that I'm able to get information about the rating from the rating microservice, and I'm also able to rate. Still no recommendations though, so once I start the recommendation component and it registers with Eureka, so after maybe 15 to 20 seconds, Eureka is going to say, okay, this service is up and running, and if another microservice asks for an IP address, it will give it. So let's just monitor Eureka and see, okay, recommendation is already up and running, so it will take a couple of seconds for Eureka to declare these microservices up and running, and I'm just going to click between books. And at some point in time, okay, there it is. So now I have the recommendations already present because that microservice was able to boot up, and now I'm able to see it. If I stop it, immediately recommendation is down. And if I click here, recommendations are no longer available. It's the exact behavior that we want to achieve with microservices. So if a microservice is not present, it should not affect the entire, the rest of the application. You would typically want to use something like Netflix Hystrix, which is a circuit breaker for this. It allows you to encapsulate the communication between microservices. So if one microservice is down, it's just like a light switch. It's going to turn it off, and maybe you would like to, in my situations, I'm not providing any output, but you could, for example, instead of recommended products, you could present maybe similar products or most often purchased products or something like that. So an alternative information which you can obtain from a local database. So in order to transition from a monolith into a microservice, what I did was each of these 4 components, logical components, I just started them as a separate set of microservices, and instead of using in-process communication to talk between components, I have switched to a different protocol. So basically, I'm using a REST client and a REST service, or if you have, or if you want, you can use any other type of over-the-wire communication. For me, my preference is using Thrift, which is an RPC protocol developed by Facebook. It basically allows you to create APIs, APIs which can be consumed by other microservices. The advantage it has over REST is that it's much more performant. I'm not sure about the numbers, but I would say that it's in the range of thousands faster because it uses compression on the payload and it uses a much faster protocol, etc. The good thing about it is that you have clients for pretty much all of the well-known programming languages such as C#, Java, Python, Node, JavaScript, etc. So you're able to have microservices which are written in different languages and they can talk to each other. So as you can see, transitioning from a set of monoliths into a microservices is very easy, but if you have the internals of your application already decoupled. It turns out that microservices are nothing more than a deployment model, but only if you have a well-structured monolith inside. So coming back to the initial slide, if we talk about whether you should choose a monolith or we should choose microservice architecture at the beginning of your project. These are the two opposites, and actually there is a third option which is called a structured monolith. The difference between the structured monolith and the conventional monolith is that as you can see here, a standard monolith has a monolithic code base and a monolithic deployment model. On the other hand, a structured monolith, it has monolithic deployment, so you're able to deploy your application as a monolith, as a single process. Therefore, you don't need the DevOps things, you don't need rapid provisioning, monitoring, central logging, etc. All of these things that microservices, let's say, bring, because at the beginning of your project, you actually have no benefits from these. On the other hand, you have no monolithic code base. So the components are well-structured, well-packaged inside their own packages. I will even advise using something like Maven, Gradle, or Jigsaw in order to further separate the code base, so you're not able to create dependencies between the classes which reside in these different components. So don't make everything public, because then you would be able to access classes from one package to another package. Instead, only application services should have public APIs, but your internals should be maybe with package visibility or private visibility. So please use these features which Java provides. And in my situation, I'm using actually Maven to further divide the components into separate Maven modules. This way, it's not easy for me to create a coupling between two components. Why? It's because if I want to, let's say, access a different component, I need to add a Maven dependency, and Maven will protect me if I make, let's say, circular dependencies, etc. So making coupling between components which are designed this way, it's much harder to do than if you have just a monolithic code base where everything is public. In that situation, all of the developers will surely make a mistake and introduce coupling into your code base. So with a structured monolith, what you get in advantage to a conventional monolith is you have components, you have high cohesion and low coupling between your components. And only after some period of time, if you decide to move to microservices, then you can make this transition. So in addition to already having not having a monolithic code base, you will also not have a monolithic deployment. So with microservices, you will basically have each of those components running as a separate microservice, which brings all of these additional benefits. You can use polyglot programming, meaning that you can use whatever programming language you want for your microservice. You can use different technologies, and each of these microservices will be separately deployable, upgradable, etc., etc. So the point is, if you start with a monolith, with a conventional monolith, which is a single code base, it will be very difficult for you to transition into microservices. But choosing a structured monolith where code is organized internally, switching to microservices will be an easier task for you later on when you decide to do it, because this will probably happen maybe in 6 months or 1 year after the start of the project. So what are the architectural prerequisites that you need to be using if you want to venture into microservices later on? First thing, I strongly advise to forget about layers. They are, let's say, a cargo culting thing, meaning that we are used to it, but there is actually no real benefit of using layered architecture. Instead, just package your components, your classes into component packages, so where each package represents a certain functionality in your application. So it could be a business functionality, such as book catalog, shopping cart, etc., or it could be a technical component, email, messaging component, etc. Then you want to be using some type of practice that allows you to decouple components into separate functionalities. My favorite practice is, of course, domain-driven design. The bounded context pattern is a very good way of defining the boundaries for a single functionality, for a single component, which later on turn into boundaries of the microservices themselves. Then you want to use a database per component and per microservice, because, as I mentioned, if you have a common database, that means that you are coupled on infrastructure level, and downtime or changes in one microservice will surely affect another microservice. You want to be using replication of data through some type of message bus. You could use RabbitMQ, Kafka, or whatever messaging you're used to, and maybe do it on your own, or maybe use something like Spring Cloud Stream, which is a very good way of sending events over these messaging brokers. And one other practice you could be using is the so-called ports and adapters architectural principle, or also known as hexagonal architecture. It is the thing that are used to switch from one type of communication to a different, let's say from an in process to a REST or to a Thrift. Basically, by wiring different implementations for a single API, you're able, with configuration, to switch from one type of communication to a different type of communication. So, to sum things up, this is a quote by Simon Brown. He says, if people can't build monoliths properly, then microservices won't help. Because as I demonstrated, it is the same design principle that work for structured monoliths and for microservices. Microservices are nothing more than a different deployment model. If you get your boundaries correct at the beginning, you're able to deploy them, those components as microservices. So, in other words, if you have a monolith that looks like this, your microservices will surely represent something similar. Okay, thank you.